chapter 8. We're doing a little more upper level math now. So today we're doing Pythagorean Theorem and then we'll lead into some trig and that sort of thing. Okay, make sure to take good notes. Make sure to ask questions tomorrow in class. Make sure everything's ready to roll. Alright, for a right triangle, let's label this so we know what's talking about. First thing, it has to have a right angle. Doesn't have a right angle, it's not a right triangle. Okay, so if it's not labeled, you cannot assume it's a right triangle. Alright, these two sides are called legs, just like a isosceles triangle, if you will, but they don't necessarily have to be the same. And then the longest side is called the hypotenuse. Okay, so these are terms that you need to know. The two angles, this angle 1 and this angle 2, are not necessarily the same, so don't assume that they are. And the legs aren't necessarily the same, so we need to make sure that we don't assume those are equal either. Alright, the Pythagorean Theorem, this is the big idea for the day. If you take the sum of the squares of the legs of the triangle, then it's equal to the square of the length of the hypotenuse. And we kind of saw this on the computer activity that we did the day before. Alright, Pythagorean triples. This is a set of non-zero whole numbers, a, b, and c, that satisfy the Pythagorean theorem. And this just happens to be a short list of it. There's a whole lot of these. But they're in order from a to b to c. C is always the biggest number. And all of these are non-zero, because you can't have a side of a triangle that's zero. They're whole numbers, because we could have other numbers that still work in Pythagorean theorem. But these are whole numbers that work in the Pythagorean theorem. Alright, so these are kind of ones that you might want to remember. This one is a carpenter's square. If you work with a carpenter, sometimes they'll use this. I've had a couple kids tell me that before. But some carpenters will use a 3, 4, 5 to square up things. So, might ask your dad about that. Alright, find the length of the hypotenuse. We want this length. So we take legs squared plus legs squared equals hypotenuse squared. And then we just take our calculator and we start solving. So we do 20 squared plus 21 squared, and we get 841 equals c squared. And then I take the square root of both sides. So I'm going to do square root of 841, and that is 29. So then this would be a Pythagorean triple because it's a 20, 21, 29 triangle. It has all whole numbers. Alright, this one didn't give us a picture, it just gave us words, but we can do it. It says a hypotenuse of length 25, so that's C, and a leg of length 10, so that's either A or B, it doesn't matter which. Find the length of the other leg, so we'll do A squared plus B squared equals C squared. And we're going to do some math. Alright, 10 squared is 100, 25 squared is 625, so we're going to take 625 minus 100, get 525. So then we'll take the square root of both sides, and you get 5 square root 21. Whether you do it by hand or you type it in a calculator, it should come out that way. Alright, this is a leg, so it can be either A or B. This time we'll call it A, so we'll do A squared plus B squared equals C squared. Alright, we'll do some math. So we know 20 squared is 400, 8 squared is 64. So take 400 minus 64, get 336. So then we take the square root of both sides, and we get 4 square root 21. Okay, depending on how we need to leave our answers. Right now they're not telling us to leave decimals, so we're not going to leave decimals yet. Alright, hypotenuse has a length of 12, that's your C. One leg has length of 6, we'll call that A. Find the length of the other leg, so A squared plus B squared equals C squared. And we start doing some math, so we take 12 squared is 144 minus 6 squared is 36. We get 108. And then take the square root of both sides. So we take square root of 108. We get 6 square root 3. Okay, Pythagorean theorem's pretty straightforward. There's not a lot of craziness. Alright, so the converse of this, you can use this theorem to decide if a triangle is a right triangle or not. So this says if the square of the length of one side is equal to the sum of the squares of the lengths of the other two sides, then the triangle is a right triangle. So if you plug the numbers into Pythagorean theorem and it works, then it's a right triangle. Okay, so then I give you this triangle. I put a box on it. Maybe I shouldn't have, I don't know. But we can call this A, and we can call this B, and we can call this C, and let's check it and make sure that it actually works. So we do 84 squared plus 13 squared equals 85 squared, and we're going to do some math. So 84 squared plus 13 squared gives me 7,225. 85 squared gives me 7,225. Those are equal. So is this a right triangle? Yes, it is a right triangle. If it didn't work, then it's not a right triangle. Alright, so how about this one? It says it has a 16, a 48, and a 50. So we'll do 16 squared plus 48 squared, and then you always use the biggest number as what could be your c squared. Okay? So we'll do 16 squared plus 48 squared, get 2,560, and then 50 squared is 2,500. So no, this is not a right triangle because these are not equal. Okay, it has to be equal in order for it to be a right triangle. This is actually an acute triangle because we have theorems for this. The top is the words of this theorem. I would focus on the bottom part. This is the part that is a little more concise. It says if c squared is bigger than a squared plus b squared, then it's obtuse. Okay, straightforward. You plug it into Pythagorean theorem. If c squared is bigger, it's obtuse. So you know that means that if c squared is smaller, then the triangle is acute. So if you plug it into Pythagorean theorem and the a squared plus b squared side is bigger, then that's acute. So I can give you any three numbers and ask you what kind of triangle it makes. So let's try that. We've got a 6, 11, and a 14. The 14 would be your C. 6 and 11 would be your A and B. So 6 squared plus 11 squared, and then 14 squared, and we're going to figure out what that does. So 6 squared plus 11 squared, we get 157. 14 squared, we get 196. So C squared is bigger, so that is obtuse. Because the longer that side gets, the wider that angle gets, so it makes an obtuse angle. Alright, 7, 8, and 9. So 7 squared plus 8 squared on one side, 9 squared on the other. So 7 squared plus 8 squared gives me 113. 9 squared gives me 81. So they're not equal. So this would be an acute triangle because the a squared plus b squared side is bigger. Okay? Pythagorean theorem is the big name of the game for this.